Hi everyone, this is Mrs. GA, and today we're going to start solving quadratic equations. I have a quick warm-up for you guys to try, so please pause the video and give it a shot. All right, go ahead and check your work here. For me, when I am simplifying a radical, I like to take the number in the radicand, that's on the inside of your square root sign, and I like to see if it's divisible by perfect squares. So this one, I'm going to write it as square root of 4 times 2, and I know the square root of 2 is, or the square root of 4 is 2. Here, anytime you have the square root of a quotient, you can actually split it up into the quotient of 2 square roots. Square root of 7 you can't simplify, but 36 is a perfect square. For part C, I just tried dividing by different perfect squares, and I saw it was divisible by 16, so that's why the 4 is out front, and the negative stays out front. Then same for part D, I know that 18 is divisible by 9, which is a perfect square, and 121 is also a perfect square. So before we start solving quadratic equations, I'm going to do a little review on the different methods of factoring we're going to use today. Hopefully this is review from Algebra 1. Factoring is going to be an extremely important skill, so it's super important that you know all of these methods and can use them easily. So the first thing you should always look for whenever you are factoring is a greatest common factor, or a GCF, which is essentially the largest number or variable that you can divide out of every term. So when I look at these two terms in my binomial, I have a 2 and an 8, so I know the GCF of that is going to be 2. And then if I have x squared and x, my greatest common factor would just be x. It will need to be the lowest, the variable with the lowest degree. And then if your leading coefficient is ever negative, so that means the term with the largest degree, if it has a negative coefficient, you should also factor that out. We never want our leading coefficient to be negative. So in this case, I'm going to factor out negative 2x from all of my terms, and then that factor moves out front. It doesn't disappear, it does need to move out front. Then I do my division and I see what's left, which would be x and negative 4. So this would be the fully factored form of that expression. And note that negative 2 is a factor, x is a factor, and x minus 4 is a factor. All right, the next thing we should be able to factor are trinomials where your a value is equal to 1. So there's lots of different techniques for this, so whatever you'd like to use is fine. Some people can just do this in your head. If you need to, I like to use this method sometimes called magic x. So you take your c value and you put it on top, in this case that's negative 12, and you take your b value, which is negative 4, you put it on the bottom, and you ask yourself what multiplies to make negative 12 and adds to make negative 4. So those two numbers would be negative 6 and positive 2. So those become the numbers within your factors. But your factors are x minus 6, that whole thing is your factor, and x plus 2. So here I have my two factors of my trinomial. All right, so we should also be able to factor trinomials where your a value is greater than 1. So this can sometimes be a little trickier. You can definitely just kind of guess and check and plug through different factors until you find the right ones, or you can use a specific method. I like to use a method, it's called the bottom-up method. You don't need to use this method, but it's one that I like to use. So for this method, what you do is you take your a value, which in this case is 6, and we're going to temporarily multiply it to our c value. So I'm going to rewrite our expression like this. Now notice this is definitely not our original expression, so this is just kind of an intermediate step. And then I look at this expression and I ask myself, can I factor this? And this one we can. It'd be x minus 9 times x plus 2, or you can use magic x if you need. However, if I multiplied this out, even in my first step, x times x is not 6x squared. So this will not be my final answer. What I need to do now is I need to look back at that a value that I multiplied. Since I multiplied it at the beginning of my process, I need to divide it out here and here at the end. Now, when you do this step, you need to look at the remaining number. If that number can be simplified, like 9 over 6, you need to simplify it. So I simplified that to 3 over 2, and then I simplified this to 1 over 3. Now from here, this is why it's called the bottom-up method. Any number that's left on the bottom, I'm going to move it up front in front of x. Now, sometimes this will simplify out to a whole number, and that's totally fine as well. So this becomes 2x minus 3, and this becomes 3x plus 1. And if you do a quick double check, here we do get 6x squared, and then plus 2x minus 9x, which gives us negative 7x, and then minus 3. So it's always good to do a little double check whenever you're factoring, because it's pretty quick to do, and it really helps you avoid, if you've made a silly mistake, to fix it. But once again, whatever method works for you, maybe you can just do this in your head, maybe you have a different method you like, that's totally fine, as long as you have some way that you can quickly and efficiently factor a trinomial like this. All right, the next common method that you'll be using this year is difference of two squares. So hopefully this looks familiar. Whenever you have a difference of two perfect squares, there's kind of a formula that will fit this expression. It's just going to be a plus b times a minus b. So please note that these both need to be perfect squares, and it does need to be a difference. And if this is a squared, notice that the values in here are just a and b, so you take the square root of them and plug them into this formula. So let's look at this first one. I see that both are perfect squares, and this is a difference. If you'd like, you can list out what your a and b values would be, simply the square root of each term. Notice that a and b are both positive numbers. I know there's a negative here, but the a and b are always positive, and then we just plug them into our formula. So it'll be 3x plus 5 and 3x minus 5. And again, you could do a quick little double check to make sure you end up with what you started with. But difference of two squares, you're going to use it a lot, so just know to look for it. And then, of course, sometimes you're actually going to need to use a combination of different methods. So remember what I said, the first thing you should always look for when you're factoring is for a GCF. And in this case, there is a GCF. Notice that all of our terms are divisible by 2. So I'm going to go in and I'm going to divide out 2 from every single term, leaving us with 2 times x squared minus 13x plus 42. And then from here, I'm going to ask myself, can I factor more? So just because you've done one method doesn't mean you're done. So this trinomial is actually factorable. Again, if you want to use that magic x method, you're welcome to. So you ask yourself what multiplies to make positive 42 and adds to make negative 13. So that'd be negative 7 and negative 6. So my factors are 2, x minus 7, and x minus 6. So we have 3 factors. And the way we would read this, we would say 2 times x minus 7 times x minus 6. We never actually say the word like parentheses when we're reading out factored expressions. So always look for, a combination of methods. Check for GCF first, but oftentimes you will be able to factor more after that. All right, so here I have some for you to try on your own, so please pause the video and hit play when you're ready to check. All right, go ahead and check your work here. For the first one, for part A, you can do difference of two squares. For part B, it's just a trinomial with an A equal to 1, so it should be pretty straightforward. For part C, I use that bottom-up method, but you should end up with 2x minus 5 times x minus 2, regardless of the method you used. For part D, be careful. Although these are both perfect squares to start, if you use your GCF first, then later you can use difference of two squares and you are fully factored. So if you go straight into GCF and you have 2x plus 4 and 2x minus 4, this is not fully factored. Each of those actually have a GCF of 2. So again, general rule of thumb, always look for that GCF first and then see if you can factor more after. For part E, remember if your leading coefficient is negative, we always are going to want to factor that out. So when I do, the remaining trinomial is easily factorable. And then for part F, this is a combination one. First, we have a GCF of 2, and then this remaining trinomial, you can factor it however you like, but you should end up with 2 times x minus 3 times 3x plus 4. And please make sure you don't lose that factor of 2. It is called a greatest common factor, So it needs to be included in your final answer. So now that we've done our quick factoring review, we're going to talk about some different methods for solving quadratic equations. So one method that we're going to talk about today is graphing. So for this method, we just want to make sure we set one side of our equation equal to 0, and then we graph our function and we look for the x-intercepts. Those are going to be our answers. I do want to point out that this only works if you have exact x-intercepts, so if you have a pretty nice equation or if you have a graphing calculator. So if you don't, that's probably not the method we're going to want to use. And it's rarely the method I would choose to use, but it's still a good one to know. The next one is the square root method. One thing I do want to point out for this one is that this method only works if your b value is equal to 0, meaning you don't have any term with just x. But if this is the case, this is a really good method to use. So you just isolate your x squared term, and then you take the plus or minus square root of both sides and simplify if necessary. Please don't forget to take the plus or minus square root. Anytime we are the ones initiating a square root, you need to put that plus or minus out front. The third method we're going to talk about today is factoring. So we just did our factoring review, but those were expressions. So if it's an equation, we set one side of our equation equal to 0, then we factor the expression if possible, and then to help us actually solve, we're going to use that zero product property. So I do also want to point out that not all expressions are factorable, so this method might not always work. But if the equation is factorable, this is probably the method that I would choose first. Now these next two methods we're not actually going to cover in this lesson, but we will cover them in a later section of this unit. First, the quadratic formula, a super important method for solving a quadratic. Here's the quadratic formula. Hopefully you still remember this formula. If not, start memorizing it now. It's super important. However, we're not going to be covering this specifically today. Another method for solving quadratics that we'll talk about in a later time is completing the square. But again, today we're going to focus on those top three of graphing, the square root method, and factoring. All right, let's give a couple of these a try together. This is also really a good review for graphing quadratics. So you can see for this one, our equation is already set equal to 0. So now I need to graph, and I'll start by finding the vertex. So I'll use negative b over 2a to help me find that x value. So negative 4 over 2 times 1. So my x value is going to be 2. And then I can plug that into my function. So 2 squared minus 4 times 2 minus 5. So f of 2 should equal negative 9. All right, so we can see that our vertex is 2, negative 9. And then for that vertical growth pattern that we learned earlier, it's a times 1, 3, 5. And in this case, our a value is 1. So it's just a 1, 3, 5 vertical growth pattern. So let's start with our vertex. And then I go up 1 over 1. And then from that point, I'm going to go up 3 over 1. And then from that point, I'm going to go up 5 over 1. And then I could continue that pattern. I could go up 7 over 1. But we have plenty of points here. And then I'm going to reflect those points over our axis of symmetry. And we have a graph. And you can see for this graph, we have really nice x-intercepts right here and here. So those are going to be our answers. We're going to have x equals negative 1 and positive 5. Okay, let's look at our next equation. So for this one, let's start by setting our equation equal to 0. And let's find our vertex again. So we have negative 4 over 2 times negative 2. So that gives us an x value of negative 1. So let's find that y value. So here we have negative 2 plus 4 minus 2. So you could see that our vertex is actually going to end up being our answer because it is an x-intercept as well. So our vertex is -1, 0. And in terms of our vertical growth pattern, you'll see that that a value out front is -2. So remember, we can take our a value and multiply it by 1, 3, 5. So it'll go negative down 2, down 6, down 10. So we don't really need that for this example because our x-intercept is really what we're looking for. But if we wanted to be thorough, we could add in a couple extra points using that vertical growth pattern. But here you'll see that we only have that one x-intercept, which means that we only have one answer. So it's very possible that we have two answers for these types of problems, but it's also very possible that we have only one answer or even no solution. Imagine if we had a downward facing graph and the vertex was below the x-axis, it would never cross your x-axis and you'd have no solutions. I do want to point out that we would call this a double root. It's kind of like we have the same answer twice, although we only write it once. And then we'll kind of come back to that later on in this chapter. So here you can see how we can solve quadratic equations by graphing. All right, now I have two for you to try on your own, so please pause the video and give them a shot. All right, go ahead and check your work here. Make sure you have the correct vertex, and then an accurate graph will give you these nice x-intercepts, which are the solutions to your equations. All right, so now we're going to try a new method for solving. So this is that square root method, and we're going to look to use this method anytime we don't see that x term, but we see that x squared term. So our first step in these is always going to be to isolate our x squared term. So I'm going to start by adding 31 to both sides, 80, and then I'm going to divide both sides by 4, so x squared equals 20. Now here's the step we need to be careful about. To get rid of our square, we need to take the plus or minus square root of both sides. I need to see that plus or minus out front. If you're missing the minus, you're missing half of your answer. So from here, all we need to do is simplify our radical. So we know that 20 is 4 times 5. So we get plus or minus 2 root 5. So we have two answers, positive 2 root 5 and negative 2 root 5. And it is completely fine to leave your answer like this, or you can write them separately if you prefer. All right, let's try this one together. So again, I'm always going to isolate first. Now here, I end up with x squared equals -3. So when I go to take the plus or minus square root of both sides, I have the square root of a negative number. So for this one, we know that there's no real way to take the square root of a negative number. So for this, we would say no real solution. The reason why I'm not just saying no solution is later on in this chapter, we're going to talk about a way to find what are called imaginary solutions, but for today, we'll just say that there are no real solutions because you cannot take the square root of a negative number. Now let's look at example C. So I know that for this one, we do have an x term and not an x squared term, but we have a binomial that is squared. So we can kind of treat this as a single squared term. So let's try to isolate our squared term. So I can do that by multiplying both sides by 5 and then dividing by 2. And so that gives me x plus 3 squared equals 25 over 2. Now, to clear the square of this entire binomial, I can take the plus or minus square root of both sides, like this. And then I can finish solving for x here by subtracting 3. So we have -3, I'm going to put that out front, plus or minus the square root of 25 over 2. Now I'm going to simplify this expression on the side here. We can't leave our final answer like this for a couple of reasons. So First, if I'm going to simplify this, I can treat it as two separate radicals like this. We know that square root of 25 is 5, so we can simplify that, but we can't simplify the square root of 2. Now, although we've simplified our radicals, we do need to do one extra step, which is called rationalizing your denominator. We don't want to leave any of our answers with a square root in the denominator. So to clear this square root, well, if I multiply it by square root of 2, well, then that just becomes 2 without the square root. However, I can't just multiply the denominator. I need to multiply our numerator by the same thing. So this ends up becoming 5 root 2 over 2. So make sure you never leave a radical in your denominator. Again, this process is called rationalizing the denominator. And this will be a step that I expect you to take before you provide your final answer. So our final answer will be -3 plus or minus 5 root 2 over 2. And we can leave our answer like that. If you would like to separate it into two separate answers, it'd be -3 plus 5 root 2 over 2, and then -3 minus 5 root 2 over 2. So I would just say write it as a single succinct answer, but if you want to write it as two separate answers, that is fine as well. All right, so now I have a couple for you to try on your own. So once again, pause the video and give them a shot. All right, go ahead and check your work here. So for this first one, please note that, again, you cannot take the square root of a negative number, so we have no real solutions. Here we end up with the plus or minus square root of 28, so make sure you simplify that to plus or minus 2 root 7. And then for this one here, make sure you're simplifying the square root of 40 over 3. You do get 2 root 10 over root 3. You need to rationalize, so we end up with 2 root 30 over 3. So not a super nice looking answer, but this is correct. -1 plus or minus 2 root 30 over 3. All right, and now we're going to move on to our last method for today. And again, if this method is possible, this is going to be the method that I choose to use 100% of the time, and that's factoring. Now, a really important first step of factoring is always setting our equation equal to 0 first. And then we look at it and we ask ourselves, can I factor? In this case, we can do x minus 9 times x plus 5 equals 0. Please do not lose your equal sign in any step. It needs to be an equation in every single step. From here, this is when we're going to use the zero product property. And I oftentimes will abbreviate this with ZPP. So for the zero product property, we take each individual factor and we set it equal to 0 separately. Because if this factor were equal to 0, our entire equation is equal to 0. Same if this factor is equal to 0, the entire side would be equal to 0. So I can say x minus 9 equals 0, x plus 5 equals 0. So our two solutions are x equals positive 9 and x equals negative 5. So eventually you won't need to show this step of your zero product property. It's fine if you go straight to here. Please note that your solution is always opposite of the number you see in your factor. The one thing I would like to see though is that that equal sign in every single step. This is an equation, not an expression, so don't lose the equal 0. All right, let's try the problem in part B. So first I'm going to make sure I set my equation equal to 0. And this one I'm going to try to factor using that bottom-up method. So we have x plus 2 times x plus 2. So we have the same factor, but then remember I need to divide both by that a value. So I have x plus 1/2. And since it's the same factor twice, I can just square it, or you can write the same factor twice and then just make sure to move that a value up top. So here we have 2x plus 1 squared equals 0, which is the same, again, as 2x plus 1 times 2x plus 1. So when I go to do my zero product property to finish solving, I only need to set one of those factors equal to 0 and finish solving from there. So here I do have a single answer instead of two different answers. Because it's a single factor being squared, we would call this a double root. But we will only write a single answer here. So again, if you would like to write out each factor twice, that's fine, but we're only going to provide a single answer for this problem. All right, let's try this last one together. So we always start by setting our equation equal to 0. And whenever possible, and we want our leading coefficient to be positive, so I would never subtract my x squared term over. We want the x squared term to be positive before we do anything else. Now here it might not look right off the bat that this is factorable, but remember, we're always going to look for a GCF, and in this case, we do have a GCF, which is x. So I'm going to factor out x. Make sure you have it out front because it is a factor. And any factor with a variable has a solution. So x is a factor, so when I set it equal to 0, it becomes a solution. And then I set my second factor equal to 0 as well, and that gives me a second answer. So here I have two solutions, again, 0 and 8. And just remember, it's totally fine for one of your solutions to be 8 or 0. Please don't lose that factor. If you lose this factor, you lose an answer. So there you go. That's how we're going to be solving by factoring. And again, if the equation is factorable, I would definitely pick this method before any other method. All right, here I have these last ones for you to try on your own. So again, please pause the video. All right, go ahead and check your work here. So for part A, this one becomes much easier to factor if you find that GCF first. In this case, we could have actually divided both sides by 2, or you can factor it out front. Just note that if your GCF contains a variable, we will never divide both sides by that variable. You never want to divide both sides by x. But if it's just a constant like 2, technically we could just divide it out completely. So here we get two solutions, 3 and 1. For part B, we have a trinomial with an a value greater than 1, so factor it using the method of your choice, and we have two solutions here. And then for part C, same thing, except it is the same binomial twice, so I can write it as 2x squared plus 7, or 2x plus 7 squared. So I have a single answer, negative 7 over 2. All right, that is all for today's video. Thank you so much for watching.